Welcome back to episode 3 of STEM and Society Unplugged. On this video, my third video, we're going to be tackling heating cooling curves. Heating cooling curves simply are the representation of phase changes of compounds, elements, of anything really, and the heat energy required to do that. Heating cooling curves allow you to determine how much heat energy is required for, let's say, water, which we're going to do some examples later on. How much energy it takes for a certain amount of water to solidify into a solid to a certain temperature. Now that might be confusing at first, but once we get through examples, hopefully it makes more sense. Now, these slopes here represent phases of a liquid. We have solid, liquid, gas. Those are pretty simple. I think you should know those. But as you get more into the chemistry part of heating and cooling curves, you'll encounter M and V. They might change depending on how you're being taught, but they mean the same thing. These plateaus here represent phase changes. So either the M would represent a solid going into a liquid or a liquid going into a solid, and V would represent liquid going into gas or gas going into liquid. And defined the energy required to do a phase change. If you're doing solid to liquid or liquid to solid, you would do the Q of fusion. Q equals heat energy amount equals the mass of your substance times the heat of fusion of that substance. Whereas the Q of vaporization, same thing, heat energy required to do vaporization or evaporation equals the same mass, depending on you're doing the same question, times the heat of vaporization. Now that we know these, let's get into a couple of examples. You're bored? Alright, to begin, I'm going to write out a question, and then we're going to solve it, okay? How much joules are required to bring 30 grams at negative 14 degrees, 30 grams of ice, my apologies, of ice at negative degrees Celsius to water at 4 degrees Celsius. Now, whenever you're doing a problem like that, it's recommended to chart out your own heating and cooling curve and label what phase changes are going on here. So obviously we're going from a solid to a liquid, so we're going to be using our heat of fusion, and we also have to do equations to figure out the heat energy required to do this and the heat energy required to bring it from here to 4. So this will be 1, this will be 2, and this will be 3. Now, the equation to figure out the heat energy required to bring a substance up to its melting point is as follows: Q equals mass, which is 30 grams, times the specific heat of the substance, which in this case for ice is 2.092 joules per gram, times the change in temperature, which bringing it from negative 14 to 0 14 times 14. Now you just simply multiply. This will give you 807.64 joules. Now, a very common mistake at this point is thinking you are finished here with this value. No, you still have two more equations to figure out the total amount of energy that it takes to bring 30 grams of ice at negative 14 to 4 degrees Celsius. Now, we'll clear the board and do our final two equations needed. Now, next, remember, on our heat and cooling curve, we just did this to this. Now we must do the heat of fusion and the heat energy required to bring it to 4 degrees Celsius. Now the heat of fusion, if you remember, the Q of fusion, my apologies. The Q of fusion equals the same amount of mass as in the first equation, 30 grams, times the heat of fusion of a substance. The heat of fusion of water equals 334. Again, now that we found variables, it's simple multiplication. This gets us 10,020 joules. We are still not complete. We have one last equation. And our last equation is very similar to our first. Q equals 30 times a different specific heat this time, since we are at a different solid specific heat of water is different than the liquid specific heat of water. In this case, liquid water specific heat is 4.184, which coincidentally is the amount of joules required for 1 calorie, times 4. So we're going from 0 degrees to 4 degrees. And like I said, the hardest part is finding the variables, the correct values for each one of these variables. And now with some clicks of the calculator, we get 502.08 joules. Now that we found these values, our last step is to add them up, and that will be our final answer. Let me clear board once more. We can finish out this problem and hopefully give you a better understanding of heating and cooling curves in chemistry. 64 plus 10,020 plus 502.08. This gives us a grand total of 11,400 joules, give or take. The chemistry teacher might get on to you about significant figures, but in this case, we'll just keep it simple. Now, if your teacher asks for this value in kilojoules, you simply divide it by your joule amount by 1,000, and that will get you 11.4 kilojoules. And there you have it, your final answer. So 11.4 kilojoules is required to melt 30 grams of ice at negative 10 degrees to 4 degrees. Thank you so very much for watching this video. If you liked it, please leave a like and subscribe. If you have any questions, leave them in the comments below and I'll answer them. Have a good night. Stay blessed.